Okay, so in today's class, we are going to start the discussion about electric fields. So when we take about the history of electromagnetic wave and related concepts, we have several scientists who discovered different laws along the centuries and uh, like proposed really important facts about electric fields and magnetic fields. So when we talk about the history of uh, electromagnetism, we have Coulomb's law first, which talk about the force between two electric charges and how we can find the electric field at a certain point in space. When we take the history of the electromagnetism, if you have any questions, please ask. So when we talk the electromagnetism and related concepts, uh, I think if my writing is not clear, also please let me know. I think today it's not writing properly. We have Coulomb's law, which we can use to define the electric field at a certain point in space. Then we have Gauss's law. So we have two main types of Gauss's law: Gauss's law for the electric field and Gauss's law for the magnetic field. So they were important laws in order for us to like evaluate the electromagnetic wave propagation and how electric field and magnetic field behave. Ampere's law is also an important law which was introduced by scientist or engineer Ampere, who was in France, and he introduced us the fact that once we change the like electric flux or frequently over a certain surface, we can generate magnetomotive force, which is magnetic vector potential. So we will talk about that in the upcoming classes. So anyway, this is kind of just an introduction to the different laws that we are going to discuss in these lessons in order for us to understand the necessary concepts related to electromagnetic waves. So Lenz's law is also important. So Lenz's law is actually incorporated in the Faraday's law. Lenz's law is talking about energy conservation and how the nature resists the change in flux, and how the nature acts based on that and create currents or potentials in the opposite direction to uh, the rate of change of flux. And then we have Hans Ørsted, who combined all the different laws and tried to come up with the set of equations. Hans Ørsted. He was actually, combining all the laws that were already proposed and trying to combine all them, and he tried to find a combined law that can define electromagnetism. However, it was James Maxwell who was able to give like scientifically um, the four main equations that define electromagnetic waves. So anyway, James Maxwell used the previous scientist laws when proposing his own model regarding electromagnetic waves. So he used the like knowledge and theories developed by previous scientists in order to formulate his theory about electromagnetic waves, in order to formulate the idea how electric field and magnetic field can work together and interact. So in this lesson, we will be talking mainly about the electric charge and Coulomb's law. So Coulomb's law is uh, defined for the force, is defining the force between two electric charges, and based on that we can define what is the electric force that can act on a unit charge. So anyway, so Coulomb's law help us to find the electric field at a certain point in the space. So therefore, we first start with the Coulomb's law, which which is the fundamental, which is the first law that we can discuss to understand about the electric field and its behavior. So when we talk about Coulomb's law, we can define, first we need to actually understand the electric charges and how they are defined in nature, and also in science, and how they react when they are kept in a close by proximity area. So first, before going to Coulomb's law, we need to learn a little bit of facts regarding electric charges, and then then we can actually move towards the force between electric charges and how we can model that force. So if we will be first talking about the electric charge, right? So you have heard about electric charge, right? So electric charge is it's a fundamental property that we can observe in materials, in matter. So electric charges are available on surfaces, on the objects, and we can actually move electric charges from one object to another object. Anyway, uh, the uh, the electric charge is a fundamental property of the matter, right? Matter is made up of charges, atoms, and atoms are made up of protons and electrons and neutrons. So protons and electrons are electric charges, right? So electric charge is a fundamental property of nature. Of matter, actually, it's a fundamental property of matter. So matter is made up of atoms. Atoms are made up of electric charges and neutral charge. That means neutron. Anyway, the matter is made up of atoms. Atoms are made up of protons, neutrons, and electrons. So protons and neutrons, they are electric charges. So smallest known quantity of the electric charge is that of proton or electron. So electron and proton are the smallest known quantities of a charge. And so last week you told me about this issue, right? I asked them about that regarding about the attendance issue regarding with the registrar of his people, but they did not reply with a solution to that problem. So I don't know how to proceed with this. It's okay. Like if they have not provided you that access, then you don't need to really mark anything. Okay, it's okay, totally fine. So electron is a negatively charged particle, right? You know that. So electron is a negatively charged particle, and proton is a positively charged particle, right? So uh, so electron has about like minus 1.6 into 10 to the minus 19. Sorry, it has a amount of 1.6 into 10 to the minus 19 amount of coulombs. The minus sign is given because to indicate that it's a negative charge. Okay, so one electron is having charges of about 1.6 into 10 to the minus 19 coulombs, which is a very small amount of charges, and it is minus in sign because it is a negative charge that we are considering, right? I think my writing is not that good, so I apologize for that. I will try my best to write in the like clear manner. So one proton will be plus plus minus 1 point, sorry, not, I mean minus, it's plus. So I mean, just these are very fundamental things, you don't need to memorize these values. Okay, so this is plus 1.6 into 10 to the minus 19. However, you need to know it's a very small value when compared to electric charges in general, right? So the 10 to the minus 19 means a very small amount. So that means that the number of charges that are available in a proton and an electron is very small amount. And so the SI unit of measuring electric charge is coulombs. So that's about it about the electric charges mainly. We can next talk about the rules or the behavior of electric charges. Okay. So I will erase this page. So electric charges, right? So depending on their quality or the type of the electric charges, the charges tend to either repel with each other or attract to each other. Okay. So once there are two charges which are equal in sign, what does happen? What happens? Do they attract or repel? Lateral entry students, are you here? Can you hear me? Can you answer the question like 003 student? Are you here? Can you answer me? Any other student, lateral entry? Can you answer me? What is happening when there are two charges which are equal in sign are kept close to each other? Are you in this meeting? Is there anybody in this meeting? Right? So I think you have just come to the lecture and you're not in the lecture. I think you can't answer these questions because of that, right? So as you think, like charges repel or attract? right? So like charges repel because they are of same sign and they repel by nature. And then like once you have minus and plus charges, then they attract to each other. So unlike charges attract and like charges repel, right? Okay, so therefore we can actually see that the electric field is created based on the sign of the electric charge, right? So based on the sign of the electric charge that is generating electric flux, um, the uh, uh, the uh, the force and its direction can be determined, right? So once these charges are either repelling or attracting, the same force is acting on the two charges, right? So if they are repelling by same force, and if they are attracting by the same force, right? So if these two charges are the only charges that are there in the area, then the amount of force that is acting by one charge towards another charge is similar to um the force acting by another charge on uh, the remaining charge. So the same force value is also acting, right? So the force value is also same. So this is due to the fact that the Newton's law, Newton's third law mentions about the action creates a reaction law, right? Newton's third law of motion says that action causes equal and opposite reaction. Right? So if my writing is not that clear to you, please let me know. Also, when we have charges in a closed system, it could be a closed, closed volume or closed system like environment. Then the number of charges in that system remains constant. Number of charges in that system, right? In that system remains constant, right? Remains constant. However, the charges, right? However, the charges can move from one place to another in the closed system. System. But however, the charges can move from one place to another in the closed system. Uh, However, also the total charge remains the same, right? I think I will write in this one. Total charge remains the same. Remains the same. So the total charges in the closed system remains the same. So if there's a closed system and there are some charges inside this area which on a certain object or some kind of a, you know, in the space, if there are some electric charges, then those electric charges can move from one place to another. These electric charges can move from one place to another. However, the total number of positive charges total number of negative charges do not change. Like one of those charges do not vanish, right? So they move to another place in this closed system, but the total charge that in terms of positive charges and negative charges, they should be remaining the same. There can't be any deductions of the electric charges. So once inside the closed surface, right? So next we have distribution types of electric charges. That means like how the electric charges can be distributed in general, right? So these the electric charge distribution types are important for us to like do mathematical modeling of electromagnetic behaviors. So once we have the charge distribution types, there are mainly four types that we can consider. So distribution of charges can be categorized into four types. So the charges can be moving or staying in a line, right? So line charges. Then, sorry, first point charge. That means like the charge is staying on a very infinitesimal small space or object. Point charges and line charges. Line charges are the charges that are spreaded over a line of conducting material or other material. So the line charges means like the distribution of the line charges occur due to the distribution of electric or protons along a certain line, or it could be a metal wire, it could be a metal loop, or any other kind of a line like structure, right? So point charges we can denote visually using, using a dot and then mentioning what the electric charge is. So if you are going to talk about point charges, you need to use this notation to denote each of the point charge. Then like charges, so sorry, line charges. Line charges are spreaded over the line, as I said. So this line could be a metal wire or some kind of you know current carrying conductor. So line charges can be spreaded over a irregular or regular line. And then we have surface charges, right? So surface charges are spread on surfaces, right? So some people, in some situations, we can spread the electric charges over a surface. So the smallest element in that surface area is ds, which is the smallest element in that area, and the charges, the charge density, can be defined using certain parameters, right? And then we have volume charges. Volume charges means like the situation where we have charges like spreaded along the volume of the closed surface that we are considering. So the amount of charges on top of the surface determines the amount of charges in that area. So we have, yeah, we can have charges distributed all over the surface of the volume and also inside the volume. Next, we will take into consideration one sample scenario where we can use Coulomb's law to find the force between two charges. Right? So, you know that in atoms, right? So before going towards the explanation about the electric field, in depth, we can actually look at a situation where we have electromagnetic force acting on a certain certain like a electric charge due to the existence of other other type of charges, right? So we will take the electromagnetic motive force between uh, which act between two charges, right? So as I said before, there are two types of charges, and the combination of the charges being together varies differently. And once we take the electromagnetic force between the atom and the proton, then we can actually find this force between the electron and the proton using an equation. So we can find the power or electric force between proton and electron, right? So there's the electron, right? So this is, let's say, an atom, right? So this atom is holding this proton and electrons, right? So electron is in another like energy level. Proton is in the center nucleus uh, of the atom. So the force between this proton and electron, how are we going to find out, right? How are we going to do that? What are the laws or equations that we can use? This is what we are going to look into, right? So if you cannot hear me or if you have any questions, please ask. Okay, so with that, we come to the electromagnetic force between proton and electron. Okay, so the electromagnetic force is defined by electromagnetic force, I mean electric field, right? Sorry, the electromagnetic force happens between proton and electron, it's correct. And then the force between two charges are given by Coulomb's law, right? Okay, so I will explain that scenario, right? So we have Coulomb's law. Sorry, yeah, Coulomb's law, which defines the force between two charges, right? So using Coulomb's law, we can write that we need to uh, have the Coulomb constant, two charges that are in like consideration, and then over r squared, which means the radius, so the distance between the proton and the electron. And then we have unit vector, which defines as the I mean direction of the force that is acting on the charges, right? And in this equation, we have K, which is the Coulomb's constant, and that has a certain value, which is 8.854 10 to the minus 12. Right? So this Coulomb's law is also in the 10 to the minus 12 range, so it is not a big amount, right? So as the new unit here, we can put Newton meter squared over c squared, and then we have Q1, a certain value for Q1, a certain value for the charges in Q1. And so the value can be determined based on the situation. Okay, so Q1, Q2 are electric charges, and then R is the distance between the two electric charges, right? Distance between Q1 and Q2. So the distance in here means the shortest distance between Q1 and Q2. And then we have like the n hat in here is the unit vector which shows us the direction of the Coulomb's force, right? So the force between Coulomb force between two charges are given by the Coulomb's law. Its direction is given by this n hat unit vector. I hope it's clear to you. If you are not clear, please let me know. right? Is there anything that's not clear to you? Right, so we have talked a little bit of Coulomb's law. Next, we are going to be talking about one of the questions that we can solve using this Coulomb's law equation. Okay, so we will try to find the electromagnetic force between the proton and electron, right? So for that we need some data, and then after that we can complete it, right? So in this section about the Coulomb's law, I mentioned that the force uh, is acting in this equation, as acting in this equation. So the uh, the 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 force that acts between the charges always acts between the line that joins between these two charges, right? So if there are only two charges in the environment, the force that will act on both these charges because of the other charge will be will be defined, and will be defined along the line joining these two charges, right? So the forces that I said are acting on these charges along the line that joins these two charges, right? So the line that joins these two charges is this line. So this line will be always, between the two charges. Then we can actually attempt one example question. So example 1, right? So find the force on an electron due to a proton due to a proton. Find the force on an electron due to a proton, right? So in order for us to find the force, we can use the Coulomb's law, right? So Coulomb's law says K into K1, Q1, Q2 over R squared into the unit vector along the along the line joining the two charges, right? So this is the equation that you can use, and in here you need to add the the values of the charges in this equation, right? So anyway, we can substitute all the values that we know so far, and then we can try to find the final force that acts on the electron due to a proton. Do you have any questions? If you have any questions, please let me know. If it is not clear, please let me know, right? So uh, so what is the value of K? Can you write in the chat? What is its range? Like in what order is it in? Right, so I think you can do this question at home, right? You know the values of K, you know the values of Q, right? And Q2. So let's say Q1 is electron and the proton is Q2. So you know the amount of electric charges on each of these electron and proton, right? So we learned about it just a while ago. So this is 1.6 into 10 to the minus 19. So and it's the electron, we can put a minus. However, we know by by default that electron and proton are attracting to each other. So because of that, we can draw the, attraction between proton and electron, right? So this is the attraction that causes the, atoms to stay together without getting its electrons, without, losing too much of electrons, right? So the electrons are bound to the proton based because of the force that the force that acts on it based because of the proton that is available in the atom, right? So you can find the answer to this question, right, by considering that the electron and protons are used, and also the radius between these two charges is about 10 to the minus 10 range, right? 10 angstrom meters, right? So you can consider that the distance between charges is 10 to the minus 10, and then you can solve the rest of the equation. Then you can find the force, and that force, that is acting towards each other. So they are attracting, and then therefore the force that is acting on each of the charge is equal and opposite. So you can do the sum after once you have time, right? Now, next we also have to discuss about the superposition theorem of electric charges or electric fields. Okay, so superposition principle, you must have learned that already in your mathematics class, right? So superposition, right? Superposition means the addition of multiple, things, right? So superposition of the, electric forces can be computed uh, in the following manner. Okay, so the force the force on a charge, the force that acts on a charge, the force that acts on a charge in the presence of multiple other charges is the sum of the forces that acts on that charge on the charge each due to each of the other each of the other charges each of the other charges acting alone. Okay, so this superposition principle say that once you have multiple charges in the space, for example, you have charge in here and you have charge in here, likewise we have three charges, q1, q3 and q2, right? So like once we have like multiple charges, and once we have more than two charges, then we have like a situation where both the other charges, like apart from the one that we are interested in, are having are creating a force on this specified charge, right? So this is the charge that we are selecting. So the q3, if it is a positive positive charge, and if this is also positive charge, then the force that is acting on this q1 charge will be repeating, right? So it will be repenting from the other proton, right? So if this is negative, it would be like attracting to the other charge, right? So now we have seen like how like the the charge that we are considering is getting affected from the multiple other charges, right? So other charges individually like impact or create a force on this specified charge, right? So once we have several forces acting on this specified charge, we can add all of them together and take the sum vector. Right? So one thing to notice is that once we are finding the force on the specified charge, we just need to find the force that uh, that is acting on the charge that we are considering by the other like charge Q3, for example. We forget about Q2, we just consider about Q3, and then we compute the force that is generated because of Q3 on Q1. We totally forget about Q2 in that iteration, in that step. Then we forget about Q3, and then we take the total impact of Q2 on Q1. Okay, so the superposition theorem actually make it easy for us to do the calculations, because once we have multiple charges, we do not have to think about what happens simultaneously, what happens like when when there's like forces acting on a certain charge because of multiple other charges, like how are they acting on this Q1 and so on. However, like what we need to do is we need to just separate out all the other charges and first find the charge that is acting on your charge because of another single charge. Then likewise we can do for the same of the other charges. So we can isolate totally all the other charges except one, and then because of that the total, I mean, force that acts on the certain specified charge can be found very easily once we take the effect from each charge separately and adding them up. Then we can easily find the total electric charge or electric strength, electric field acting on a certain object. Right. So if you have any questions, please let me know. Right. So superposition theorem was adding all the forces that are generated due to other charges in the close by area. Right. So we take individually each of the charge, and then we try to find the force acting on the specific charge. After that, we do the same thing for the other charges, assuming that the rest of the charges are not in the space. We are only considering one charge at a certain point. So if you are not clear, please let me know. Another example we have done in the class is what we are going to look at next, right? So right, so we can actually do some sums related to these sections, but I think that we can go faster than this if we try to just cover the content related to the electric field and magnetic field fast, such that we can actually start doing the work related to electromagnetic wave propagation and related mathematical modeling. Right, I think we are taking too much time on this electric fields, I mean, and magnetic fields. However, I think we need to spend some considerable time also. However, I will not be doing a lot of examples. So, I mean, you can actually, you can try to follow the reference books that are advised for this course and try to do some sample sums that you think might be useful for you. Right, so we have different charges that are spread on the axis, and then we have like other charges which are along the y-axis. Then we have now we have to horizontally draw these actually I'm having some difficulty in drawing this horizontally. So anyway, once we have like two charges which are acting which are acting on a like a y-axis and z-axis, sorry, x-axis. This is x-axis, this is y-axis. And then once we have the charges, right, on the y-axis, and then we also have another charge QC on the x-axis. So if that is the case, then we are asked like what is the total, total force or electric total force acting on this charge, right? So let's say this charge is QC, right? So what is the total charge or force that is acting on this QC? So these other charges are QA and QB. So because of QA and QB, force is acting on this QC. So right, so we can individually consider each of the charges QA and QB. Otherwise, we can use symmetry to find that or to observe that the force that is acting by that is forced by QA on QC is almost the same as the force that is exerted by the QB particle. So the forces that will be acting on this QC will be same by both these two charges. If these two charges are equal in value, and QC is also then QC will be able to feel opposite and equal, not opposite, but like rather close and equal magnitude forces acting on this QC charge particle, right? So anyway, we can find the force that is acting by these charges on this specified charge, right? So we can find the specific force that is acting on this QC charge based on QA and QB, and then we can take the sum of each of these force components, and then by the sum we can find the total force that is acting on this QC, right? So I will let you do that question in your in your free time, then you can figure it out very easily. Next we have to start section about the electric field, right? So I think electric field is also very easy like concept to understand. So we have discussed about the Coulomb's law, and in that Coulomb's law we have discussed about the force, electric force that is acting on a certain charge, right, due to another charge in the close proximity. So the electric field is just a kind of a uh, explanation about the amount of electric field, electric force that acts on a unit charge. The amount of electric force that acts on a unit charge, right, is known as the electric field, right? So electric field is the amount of force that acts on a unit charge, unit positive charge. Uh, electric field, right? I want to introduce electric field. So, so electric field, let's say E, electric force is E over Q, right? So electric force is E over um, electric force is sorry, electric field is E over, sorry, F over Q actually. Electric field we can denote using this. So electric field we can denote using the force and the uh, charge value. So force, if the force between two charges is F, and the charge which is the test charge value is Q naught, right? So the electric field is given by E, right? So E is a vector, F is a vector. That means electric field or electric field. This is the electric field. Electric field is a vector, and the force that acts between two charges is the given by F, and this F is calculated assuming that uh, the the charge which is like we on which we are measuring this force is a unit charge. So unit positive charge, right? So we are using unit positive charge as the test, as the test charge. And then this test charge uh, will be used to find the electric field in the area. So the force in that area, right? Electric force in that area. So we can find using the force divided by the unit positive charge, right? So that is basically regarding electric field. So if for example, if we have a certain, like charge particles and volume of charge particles, and then we stay near that uh, let's say this is q1, we will stay away from q1, and then we will try to measure the amount of electric field that is at any point away from the source charge, right? So by doing that, we can find the electric field in that certain region, right? So electric field is defined uh, for a, for a space or a region where we can experience some electric force, right? So we can experience some electric force in the area that we are considering, right? So we need to measure the amount of force that is acting on that charge, right? So the amount of force that is acting on that charge is giving us the electric field in that region, right? So if we do not feel any kind of a force acting in this region, then we say that that region is having zero electric field. If there's no force, if there is no force, then we say that that region is not having an electric field, right? So if there's a force, then we have electric field in that region. If there's no force on the unit test charge, then there's no electric field in that region. Right? So we can define the electric field using mathematical equations. So in different ways, we can use Coulomb's law also to do that. So the way of denoting electric fields using Coulomb's law uh, is something that we can also discuss, right? So anyway, I think I will try to wind up this lecture for today, and then from next week onwards we can discuss regarding that, like how we can model mathematically the electric field expressions of uh, uh, of uh, of a certain point in the space using the Coulomb's law, right? So let's try to evaluate what we have learned today in this class, and we will try to get better clarity in our discussion in the next class. Okay, so in today's class we have basically started talking about the electric field concepts, right? So in today's class, as a summary, we define the type of electric charges, like we have electrons, protons, neutrons. So we have different electric charges, and uh, uh, their behavior is such that same type of electric charge reject each other, unlike charges attract each other. So the rules that they are following, we discussed. We also discussed about how we can define the different distributions of charges. So first we discuss about the electric charges and the rules they follow. And then we have electric, electric charge distribution types. We have different types like point distribution, line distribution, surface distribution, volume distribution, so on. So different electric charge distributions are available. And then we discussed about how we can, you know, decide the superposition of the electric force when they are, electric force and electric field eventually once there are multiple charges in the space. Under multiple charges in the space. So once there are multiple charges in the space, the total uh, total force that is acting on a certain charge varies because depending on the other charges in the environment in the nearby area. So then we talked about how we can find the electric force using superposition theorem. Right, so superposition theorem says that we can consider the force acting on a certain charge due to other charges in the network by taking each charge individually and then finding its impact on Q1. First we need to separate out two pairs, and likewise we need to do for multiple other pairs which are available, and then we take the sum of all those vectors to find the sum, like vector force, sum force on the Q1 vector, right? So those are the things I think we discussed mainly in the in today's class. Then we started talking about the electric field also a little bit. So electric field is I think the important section as well. So it's one of the important sections. So electric field is also uh, defining the force acting on a unit charge, right? So the force that acts on a unit charge is defined as the electric field at a certain point in space. So the force that will be generated in this on the other charge due to a certain source charge, so depend on the various factors such as the yeah, so we actually today we talked about the Coulomb's law as well, right? So we talked about the Coulomb's law. So based on the Coulomb's law, we learned that the Coulomb's law can be defined as kq1 q2 over r squared into n hat, which is the unit vector along the two charges q1 and q2, right? So Coulomb's law gives us the force that acts between two charges, for example, and then by using this law, we can find the force. Then we can divide it by unit test charge, and then we can find the value of the electric field in that region. Right. So do you have any questions related to that? So we have covered Coulomb's law. Then from the force that we calculate, we can find the electric field in any point in the space due to a certain source charge, right? So due to a certain source charge, electric field can happen at a point in the space, right? So at any point in the space, we can measure the electric field. So that electric field is defined as a force per unit test charge. Okay, so with that, I'm going to stop today's class. Do you have any questions?